Okay, so we went through the process of finding regression equation, correlation. We talked about R squared, talked about whether or not y-intercept has any meaning or context here, right? Okay, now, remember I talked to you about the fact that if you are given an equation, there's a subtle difference, remember, in what I've talked to you about, where if I just ask you to draw a line of best fit, then I'm asking you to kind of just eyeball it. That's a guesstimate. But if we have an equation, a least squares regression line that we have computed, right? Then we need to be able to draw in that specific line and not just try to eyeball it. So that's going to be a little bit different process, just because I'm going to expect you to show me some work, and I want to see some specific points so that we know we are drawing that exact line. Okay? So in other words, like I've drawn the graph for you, you're welcome, but it's just helpful to have that written out. So if I ask you to just draw a line of best fit, then you're just doing a guesstimate, and you're going to remember whether you tend to draw your line a little bit too steep or not steep enough or whatever, and adjust for that. But in this case, I want you to be able to draw the exact least squares regression line. So we need to use this equation, and here's where actually it's more helpful if you don't round as much, but we're going to go with what we did here, okay? So the process that you are going to do is you need to think about what your x values are, right? So think about the range of values for your x values. What I want you to do is choose an x value that's on the lower end of the scale, and then an x value that's on the higher end of the scale. So like for the engine size, for something like this, I would suggest maybe let's plug in like 1.5 for a low x, and then we want to plug in a high x, so let's plug in 4.5. Okay, they do not necessarily have to be numbers that have values in the data set, but they should be within that interval of where the values are. Does that make sense? Okay, so we're just choosing a lower x value and then a higher x value. And then all we've got to do is actually do the math, do the work. We're truly just going to plug in. So we're going to do 38.41. I'm going to need help here, guys, with your calculators. Minus 5.49 times 1.5. And we want to come up with what that corresponding y value is. 30.175. Okay, so 30.175. Sounds good. Thanks, Aiden. Okay, gonna do the same thing with this one. We're doing 38.41 minus 5.49 times 4.5. And we get that corresponding point. What is that? 13.7. Okay, 13.7. Okay. And then we are going to draw those particular points on the graph. Guys, we want to kind of denote those a little bit different way than what the points are. So I use literal points for the data values. So my suggestion would be let's do like a little X or something instead. So we want to go to 1.5, and what is it? 30.174. So that is about right there. And I'm going to put an X at that spot. And then at 4.5, and I'm at 13. My eyes are going bug-eyed. So I'm going to make this bigger so that I don't mess up. It's just under 14, right, for that one. All right, and then you guys have a nice handy-dandy straight edge with you at all times now. Did you guys realize that? You guys have your own straight edge with you all the time. Isn't that awesome? I can't use that on my iPad, though. So I'm going to do the best that I can. But, yeah, we've got to draw a straight line connecting that. Boom. Wow. Oh, my gosh. I'm really proud of that line I drew.